All right, so we are starting chapter 5 today with section 1, which is called verifying trig identities. The good news is there's not a ton of there's a little bit of content and then you got to learn how to apply it. And 5.1 and 5.2 are pretty similar, so those kind of go hand in hand. And then 5.3 is like solving trig equations, and then we'll stop for a quiz on those 3 sections. So verifying trig identities, you need all this information. So this is the slide that you need to memorize everything on. Some of this we have already talked about, so it should be a little fresh. And then the couple of things that are new, I'll review with you. So the first thing that we have already talked about is the reciprocal identities. The thing you're going to do with these by verifying, you're basically swapping something out for you're substituting in for what it is. So if you had seen something like 1 over sine, you can substitute it in for cosecant. If you had seen cosecant, you can substitute in 1 over sine. That's the idea behind this. And then secant and 1 over cosine, cotangent 1 over tangent. Tangent can be multiple things. Tangent can either be sine over cosine. It could be 1 over cotangent, and then cotangent can either be cosine or sine, or it could be 1 over tangent. So those are all things that you can substitute in for each other. The Pythagorean identities are what we haven't talked about yet this year, okay? But hopefully you remember these from Algebra 2. They are these 3 that say that sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. These can actually be verified. Like if I found a triangle and I found the sine of the angle and then I found the cosine of the angle, you would see that if you squared the sine, add it to the cosine, you get 1. So these patterns are obviously verifiable, like you can actually work it out. But these are things you have to memorize. And I'll show you, if you can at least get to the first one, I'll actually show you a trick to get to the other 2 in a minute. But those are definitely things that you're going to see a lot, okay? Pythagorean identities. Then comes even and odd, and even and odd we have also talked about, right? Even and odd, remember we said that the even ones are cosine, and its reciprocal function, which is secant, and then the odd are sine and tangent. All right, so underneath the even and odd functions is the cofunction identities. This we also talked about, but this was at the beginning of last chapter. So remember, cofunctions are ones that go in pairs, and that one is the complement to the other. Sine goes with cosine, secant goes with cosecant, tangent goes with cotangent. So last time we had these, it was with degree measurements, right? Like if I said find the sine of 30, you would give me, or find the cofunction the sine of 30, you would give me the cosine of 60. Now you're going to actually see these symbols. So if in a statement you saw this part, tangent of pi over 2 minus u, you can immediately replace it with the cotangent of u. Or what could be in the place of pi over 2? What's the degree equivalent? 90. So you would also see it written like cotangent, not like that because it wouldn't be in highlighter, cotangent of 90 degrees minus theta. And when you see that, you can replace it with what? Tangent of theta, okay? So the Greek letters are obviously what's going to be changed out there, but you can see it as pi over 2 or you can see it as 90 degrees. No problem anytime. All right, so the Pythagorean identities, like I said, I'll show you a trick. If you can learn the first one, which is sine squared plus cosine squared equals 1, then there's a trick to get from that one to the other ones. Again, you can memorize it, okay, or I'll show you this trick. So if I take that statement and I divide each of these by cosine squared, what is sine over cosine? Tangent. So this becomes tangent squared. What is cosine over cosine? 1. And what is 1 over cosine? Secant. So this would become your second one. If I start with sine and cosine again, sine squared plus cosine squared equals 1. And I divide them all by sine this time. What is sine over sine? 1. What is cosine over sine? Cotangent. And what is 1 over sine? Cosecant. So that gets you the second one. So if you can't memorize them, which honestly some of you will probably just be able to memorize that because you've already seen it once, you can memorize it. If you can't, as long as you can memorize that first one, you can derive the other 2. Okay? So basically this is your reference sheet for everything in this section. Everything you need to know to verify is on this, okay? There's a Quizlet for this chapter, which has all these on them if you want to practice it. Okay, that's a good practice tool. I think there's one from like 5.1 to 5.4, so when we get there you'll understand which is sum and difference. But there is an option for you to practice. Okay, so this first one says use the given values to find the values of the 6 trig functions. So this time it says that the sine of pi over 2 minus x equals 12 over 13, and the sine, and that should be sine of x, equals negative 5 over 13. So when we see sine of pi over 2 minus x, what do we sub in for that? Cosine of x. So this is telling me that cosine of x is 12 over 13, and that the sine of x is negative 5 over 13. Are these values that are unit circle based? No. So what do we do with these? Make a triangle. So if I make a triangle and I put cosine in the corner, this would be 12 over 13. And then I get to sine, and it already completes my triple for me, which I should know that other side is 5. But what's important about this is the negative, okay? If the sine is negative but the cosine is positive, that means the opposite sign must get the negative. Remember that the radius is always positive. The radius is always, or the hypotenuse, right, would always be positive. So if I have now my completed triangle, I know cosine, I know sine, I need tangent, which would be negative 5/12. I need cosecant, which would be negative 13 over 5. I need secant, which would be 13 over 12. And I need cotangent, which would be negative 12 over 5. God bless you. God bless you. Paolo. Probably not. No, just be careful because sometimes you will see verifying identities and they will have different variables. So the variable is important. Okay. So that's obviously using right triangle. Okay. You needed both of these to know the sign on that remaining side. If it's in the first quadrant, then it's not then it doesn't matter. It's all going to be positive. But if it moves around your triangle or it moves around your circle like this one does, you need to know the sign of the extra side, which is where that second piece of information is going to come from. Questions on that one? All right, this one says simplify the given expression cosine times the secant x minus cosine x. So this is kind of your first taste at verifying. So I need to take this statement and make it as simple as I possibly can. And there's not just one way to do a lot of these. There's a couple ways to do all of these. So it doesn't mean just the way that you started is wrong, okay? But you got to figure out how to work it out. So what would you normally do with this kind of if I said like 2 times x minus y, what would you normally do there? Distribute. So your gut is to tell you to distribute. If I do that, I said cosine of x times the secant of x minus cosine of x times cosine of x. So what is secant? 1 over cosine. Usually, if it's not a sine or a cosine, I'm going to replace it with its reciprocal functions when in a case like this. And what is cosine x times cosine x? Cosine. So here's what's weird. The squared goes on the cosine and the x doesn't get it. So it's cosine squared x is how you write it. Now what's cosine times 1 over cosine? 1. Where have you seen a 1 and a cosine squared? In your trig identities. So it is sine squared x plus cosine squared x equals 1. This isn't exactly it. I need to tweak that a little bit. So the way I get cosine on the side with the 1 is by subtracting it, right? So cosine squared. And I get sine squared x equals 1 minus cosine squared x. So this can get replaced with sine squared x. The hardest part of these, in my opinion, is knowing when to stop. Obviously, if you can get it down to a single term, that's your best bet. It's not always going to happen, though. So you just usually are writing it in terms of sines and cosines. Questions on that one? Okay, this one, and this is hinting you towards what you need to do. It actually says factor the trig expression. Eventually, they'll just say to simplify, and that factor won't be there. You have to know to factor. So the fact that I've got a squared term and then a non-squared term is just like having a 3x squared minus 5x minus 2. The difference is those variables now have a trig function on them. That's it. So if it throws you off to keep the sign on it, feel free to substitute this in its place, but then at the end, make sure you pull that sign back in. So we're saying that x is really sine here. And at the end, we can pull it back in. So if I had given you 3x squared minus 5x minus 2, you would factor it, right? Factors of 3x, which are 3x and x. And then factors of negative 2, which can either be positive 2, negative 1. I test that out. I get negative 3x plus 2x, which is not negative 5x. So then I try to switch these. This is 1, this is 2. This time I get negative 6x plus 1x. And that's my negative 5x. So that's the combination that works. And now I want to take these x's and replace them with the sign of x that I used. So 3 sine of x plus 1 and sine of x minus 2. For right now, we're just factoring. In 5.3, we'll then solve these, but for right now, we're just factoring. And again, like on a quiz, it will just say simplify, and you would need to know to factor. Questions on that one? Okay, example 4 says perform the multiplication and use the fundamental identities to simplify. Again, quiz instructions would be simplify. So if I see something that's raised to the second power, what am I going to do? And do sine of x plus cosine of x. And if it was set equal to a number, you would square root of it. You're right on that. Okay, but I'm going to duplicate it, and then I'm going to FOIL this out. So sine times sine is sine squared x. Sine times cosine, sine of x times cosine of x. Cosine times sine, cosine of x, sine of x. And cosine times cosine, cosine squared x. With me so far? Are these the same terms? Sine x, cosine x. Are those the same terms?
Yes.
Does order matter there? No, right? It's a product. So this becomes sine squared x plus 2 sine x cosine x, or cosine x sine x, it doesn't matter, plus cosine squared x. Yep. So hopefully, and again, the better you get these, the more comfortable you are with your initial fundamental identities, the easier it's going to be. You should see that you've got a sine squared and a cosine squared. And what did we say sine squared plus cosine squared is? 1. So this is 1 plus 2 sine x cosine x. And remember, I said sometimes the hardest part is figuring out when to stop. That's where you stop. There's no way to make that any simpler. Questions on that one? All right, example 5. Use fundamental identities to simplify the expression. Hannah. Mm-hmm. All right, so who can tell me what to do with cotangent and secant? Okay. So cosine over sine and 1 over cosine. Okay, then what? Okay. Which is? Cosecant.
Oh, I knew that. I'm sorry.
Don't apologize. All right, how about B? Hopefully that 1 minus sine squared is fresh in your mind, right? What can you do with that, Hannah?
The top is 1.
Go. No.
Oh, cosine.
Cosine. Right, because sine squared plus cosine squared equals 1. So 1 minus sine squared would equal cosine squared. Okay. And then the bottom one we haven't used yet, right? But what is that? What was the trig identity with cosecant and 1? What's the exact?
Cotangent squared x.
What's the exact Pythagorean identity? What plus what equals what? Or what minus what equals what?
1 plus cotangent squared x equals cosecant squared x.
Good. So if I have a cosecant minus 1, that means I subtracted the 1, right? And so that is why we can replace cosecant squared minus 1 with cotangent squared. Okay, can I go anywhere from there? What?
You make the cotangent cosine over sine.
Then what?
And you divide it by this.
So this is this divided by this, right? So cosine squared x divided by cosine squared over sine squared is the same thing as times sine squared over cosine squared because keep change flip. Then
You get sine squared x.
cosine squared. Good. And I get sine squared x. Questions on that one?
Was the answer for the first one cosecant?
Yeah. So think about, there's also a trick, right? If you have a single, it can't be a sum or a difference. It has to be a single term. If I have a single term in the top or the bottom of a fraction, and you want to move it to the other location, when you move it, it becomes its reciprocal function. So if I take cotangent and move it to the top, then it becomes tangent. And then tangent, we said, is sine over cosine. And then those cancel and I get sine squared x. So if you are moving, and it can't be like I can't take this and move it because cosecant minus 1 is a package, right? That can't be broken up. But if you have a product of two terms or you have a single term by itself on the bottom and you want to move it to the top, it becomes its reciprocal function. If you wanted to move it to the bottom, it becomes its reciprocal function. So if I had moved cosine to the bottom, it actually would have been secant. Okay? You could do that either way. So sometimes it makes things a lot easier. Questions on that one? Okay, this one says, rewrite the expression so it is not in fractional form. What do I do?
Multiply both on the top and bottom by 1.
Okay, so that's one way to do it. I can multiply by the conjugate, right? Or 1 plus the opposite. And I get sine squared y plus sine squared cosine y over, this is a squared minus b squared. So 1 minus cosine squared y. Then what? What's 1 minus cosine squared? Sine squared. So I can say sine squared y minus sine squared y cosine y over sine squared y. Then what? Because I wrote it wrong. It should be plus. Yep. Then what? Each of them have a sine squared. So I'd get 1 plus cosine y. Anybody see another way to do it? Because that's not the only way. What if instead of multiplying, I replace the sine squared in terms of cosine, right? So what is sine squared if I want to make it in terms of cosine? 1 minus cosine squared. So if I work this down this way, I can get 1 minus cosine squared over 1 minus cosine y. Then what? Can I just cancel through the cosine? No. What can I do, Ben?
Cancel the bottom and then cancel the square on top.
Nope. Can't do it.
Divide and like multiply.
Nope.
Multiply the conjugate.
Nope. So we did that. Yeah, that does work, but that's the other method, was multiply by the opposite. Is 1 minus cosine squared y factorable?
Sine.
Are those both perfect squares and the difference between them? Yes. How do I factor that?
1 plus
1 plus
cosine.
cosine, 1 minus cosine over 1 minus cosine. And I get 1 plus cosine. So you can do all the things that we do with regular numbers that we do with these, right? I can factor it, I can multiply it, I can simplify it, all that good stuff, okay? And there's a lot of times more than one way to do it. So don't think that just because your brain saw it one way, it's necessarily wrong. You should always end up at the same spot. But there's usually, should. I did say should because, you're human beings and sometimes you don't always do these, right? But you could do them more than one way. Questions on that? Okay.
Oh, can you say that?
Mm-hmm. So just a couple other things to think about. One is, obviously I showed you that one shortcut where you can kind of move from top to bottom, bottom to top. That definitely helps. Sometimes you're gonna see things. Let me try to figure. Where you have a fraction, right? And you have multiple parts in the top with a single part in the bottom. You can sometimes split this. So sometimes it's easier to split it up than it is to like multiply by the reciprocal, which is what happened if you divide. So I can actually say that this would be 1 over cosine x plus sine over cosine x. If I split it, you want to make sure you keep the bottom with both parts. That's the only difference, right? So then this would become secant of x plus tangent of x. So you could see something like that. And then the reverse. So like if I saw 1 over cosine of x plus sine of x over cosine, I can combine them. So if you've got two separate fractions, you can combine them into one. If it's the same, obviously, you can work back the other way. Just keep in mind, like all the rules of fractions and factoring and all that stuff still apply, okay? But a lot of times when you're dealing with fractions, if it's all in one, it's helpful to split it up. Or if it's split up, it's helpful to put it together, okay? So sometimes even if that wasn't like a cosine, like let's just say that was something else, like a sine, then I would give it a like denominator and combine it, okay? So a lot of times you got to think like that. So we're back on WebAssign for tonight's homework, and your classmate found shortcuts, so you could thank him for this. I put this on the module, but these are shortcuts for how to get to the like special character, not all of them, but special characters on your, you know, like when you have to hit pi, let's say. Okay, if you type pi, the pi symbol shows up. If you type the word infinity symbol, the infinity symbol shows up. So these are all, yeah, so you can thank Paolo for this. The fraction, the square root, the absolute value, all that stuff, these are all shortcuts. It's on, if you don't want to take a picture of a screen, it's on the module too. Like I put this picture on the module.
Wait, how did you do that?
He's a genius.
I just
No.
used words.
He just, he's,
To find shortcuts.
yeah.
Wait, what?
He like kept trying to figure things out. That's,
I just
you know,
sometimes think things.
yeah. So that will help you with some of the stuff, like fractions and square roots and all that good stuff. Okay. Exponents, all that stuff.
Fraction one.
Yeah.
Me too.
But the square, I've never thought of the exponent one, but it's so easy. It makes sense because that's what you do in your calculator. But yeah, you're so smart. All right. So these, again, are just to help you. WebAssign homework is on 5-1. If you want to go on there, you can start it. You've got some time to get started on it.